Well, hey there. So I thought I would go ahead and guide you through this slideshow so you can take your notes and also get some of the information that everyone in class is getting in reference to continental drift and, of course, Mr. Alfred Wegener. There is a note sheet that you're going to want to follow along with. You're going to notice that that note sheet is at the bottom of the Canvas lesson for today. So if you haven't yet done so, go ahead and pause this video and then you can open up those notes so that way you can follow along while you're going through this lesson. So after we watched the Scrat video from yesterday, we kind of made jokes about how Scrat is probably the organism that has completely changed the Earth and Earth's history the most. Of course, we know that that's not true. There's a lot more to it than just a simple little acorn that's being placed into a piece of ice that literally cracks the entire planet. So let's talk for a minute about Mr. Wegener. Alfred Wegener, as you know, we've kind of mentioned him here and there. He was a scientist, a German scientist, and he went out on these various expeditions. He was first a meteorologist, and he did a lot of research about the physics of the Earth and came up with some ideas about what he thought was happening to the Earth in the past. All of his research and his evidence led us to our very first theory about how the continents move. And so what I'm going to do is give you the opportunity to go ahead and play this video. I will explain a few things once the video is over. So go ahead and take your time and do that. So now that you found out a little bit about Wegener, of course, very interesting fact about how he died. Most people didn't realize that he's still buried somewhere in a sheet of ice out in Greenland. Couple of things to keep in mind. Wegener was doing this research in the early 1900s. There wasn't a whole lot of technology that he was able to use to be able to prove his point. And so he had all these really great ideas and he had all these really great pieces of evidence, but he was lacking one very important detail, and that was, how does this happen? You're telling me that it did, and you're showing me evidence that it did, but you can't explain how. And it's really crazy that scientists actually got together to debunk his ideas and completely call him crazy, out of his mind. He had no idea what he was talking about. He was overstepping his boundaries because he was a meteorologist first, and he was trying to understand geology. So he went through a really tough time trying to get his point proven. Of course, unfortunately, as with most scientists, he didn't get the opportunity to see just how far his theory has taken us and what we've come to understand because of his beginning theory. We've added to the theory of continental drift quite a bit. We now call it the theory of plate tectonics, and we have actual data that can help prove the how, which was the part of what was missing. So what we're going to do is we're going to go through what the evidence was that he looked at, what things he saw that helped him to understand how he knew the Earth had been shifting and that our continents had been moving. So Wegener first noticed the geology of our planet. He saw the one thing that most of us have all seen when we were kids. We look at the shapes of the continents, and we all notice that South America and Africa almost look like they fit together, like puzzle pieces. It's one of those things that the first time we look at a map and we really try to understand the continents, most of us notice that. And so that's sort of where his research started. He looked at that and got curious. Why does it look like these two continents sort of match up? And so he went out on a mission. He also happened to notice that as he was researching the different rock layers in the mountain ranges of North America on the eastern side, and as he was looking at mountain ranges up in Europe and even the western side of Africa, he saw that the layers of rock in those mountain ranges were very similar. And he even noticed that the mountain ranges sort of looked like they lined up with each other if you pulled the continents closer together. And so that was another really good piece of geological evidence that Wegener was able to use to help prove or try to prove that the continents might have actually been together at one point in time. Now, he also looked at the climate. And when you think about it, like, what does climate have to do with his theory that the continents move? They have a lot to do with it, because as we started learning and researching and being able to see inside rock layers and look at fossils and know that fossils could give us information, we started seeing that there were fossils that would normally exist in warm climates found in very cold places. So places like Alaska and Antarctica, which we know of as being very cold, we were finding fossil evidence of tropical plants and tropical animals. And so how do you explain that in a place like Antarctica, there are fossils of palm trees that would normally exist in a tropical climate? He looked at rock layers too in very great detail, and he noticed like preserved sheets of ice that were found in between other layers of rock strata. And those ice sheets were found in warm climates also. And so, just like the warm plant fossils were found in cold climates, he saw ice sheets found in places where there were warm climates. And so he also asked the question, how do you get ice sheets in a place that we know of as always being warm? And so that's where climate fits into this. It sort of works along with the rock layers and the fossils. Now, the other thing that was really important, and I've talked about it already, is his fossil evidence. And so a lot of us forget that coal beds, coal fields, coal is the dead remains of organisms from millions of years ago. Their bodies get compacted, and coal is usually a very dark gray, blackish color. And those coal beds, they are very important because we can use coal in the same way that we use oil to run as fuel. It's pretty much the dead remains of organisms. Now, remember, most of your rock layers are made up of minerals, which are non-living. So anytime you find pockets of oil, natural gas, and coal beds, you're looking at the stuff basically that came from once living organisms. And so there were several coal beds that he was researching in rock layers that he noticed matched up in the same way that he saw the rock layers match up in the mountain ranges. He found these layers of coal in rock layers that matched in Europe and North America. And that's what this image shows here, how you can see coal beds or layers of coal found in between other rock layers. The other thing that was really a big deal was the fossil of the Mesosaurus. So the Mesosaurus was known as a swimming dinosaur-like creature. The thing was, though, scientists knew that the Mesosaurus couldn't swim from Africa to South America, from South America to Africa, and be able to survive that distance of a swim. But yet fossils were found of the Mesosaurus in both Africa and South America, specifically in Brazil. And if we went back to that whole puzzle piece idea, where we thought South America and Africa sort of combined and came together like puzzle pieces, oddly enough, the fossil evidence found of the Mesosaurus matched with those same locations. And so Wegener was able to look at that and think, well, not only does it look like these continents fit together, but now we have fossils that appear to have been located in those places as if those continents were originally together. So he did all this research, and this is how the theory of continental drift was actually born. In 1912, Wegener wrote this long paper where he presented all of his evidence, and officially the term continental drift came about at that time. And so this paper was meant for all of the scientific world to read. And you notice it's not in English, it's in German. And that paper became very important because this was the first time that he took all of that information he had been researching for years and presented it to everyone. And as we know from the video at the beginning, It was not received very well at all. Actually, to the point where most of his colleagues laughed at him. They called him crazy. Um, they thought he was out of his mind, and there were very few people who even took his theory seriously. Um, he lacked the how. Okay, so the continents move, but how do they move? Is there some special alien force underneath the continents that are pushing them around? No one knew the how. And so, since he couldn't figure out how, he didn't really have a lot to stand on to back up all the evidence that he had found. He did go out later, as you saw in the video, and he continued to do some research and unfortunately was found dead up in the cold areas of Greenland and never really got the opportunity to see that theory go further. Of course, his theory was proven much further in the 1960s, but keep in mind, we're talking about 1912 to about 1962. You're dealing with 50-ish years before people really had the background and understanding of how the continents were moving to be able to then add to his original theory. He is still presented one of the greatest theories of all time. And of course, he was recognized for that. Um, as said in the video, they named a couple of places after him, and he did receive the recognition. He just was not alive to see it. So at this point, you have a guide sheet for your notes that kind of goes into the evidence and goes into a little bit about Alfred Wegener. Make sure you play this over again if you need some additional time to listen to me discuss it. Make sure that you complete and submit those notes so that way you have a guide to study for your next test. And please let me know if you have any questions.